All right, for Chapter 3, we start off by going over the numeration system, and please make sure you've read pages 85 through 99 before you go through this video. On page 85, you'll see a table, and it'll introduce you to the Hindu-Arabic number system, which is the system we use today. This was developed by the Hindus and transported to Europe by the Arabs, and then brought over from Europe here to America. We go off of the base 10 number system. It's really easy for us because we have 10 fingers, and so as kids we all use our fingers to count because we do use the base 10 number system. Our digits are 0 to 9. And we're going to start off by talking about place value. Place value here, I've just given you a few. Obviously 100,000 is not the biggest number we're going to talk about today, but I just wanted to show you we're not always comfortable with writing our base 10 numbers with exponents. So you need to know, and we'll use it a lot this semester, that 1,000 is 10 to the third. 10 times 10 times 10. 10,000 is 10 to the fourth, and we ask our students to do that at a younger age than you would probably think. If we were in this class, in a face-to-face class, we would start off with an activity, and I just Googled it because as teachers, you're going to get a lot of your ideas from the internet. Right here, a very good foldable that we would make if we were in this class is this first one right here. We write, and I would give you a sheet of paper, and I would ask you to write out any number you want, but we would expand it. And so if your number was 3,296, you would write that as 3,000 plus 200 plus 96. And that's the expanded form of that number. But if you fold it together, you would see that as a numeral. There are several ideas here that you can use. Right here, this is a good activity as well. Your students are going to need to know it in numeral form, word form, expanded form, etc. Another really cute activity that I've seen done with this is using paper cups to do it. So right here, this number here, 132, we can say is 100 plus 30 plus 2. And you'll see a lot of different ideas when you start looking for them as teachers. I like this because on here they've written a lot of different digits, and so you can look at a lot of different numbers. As far as when is this taught, I want to show you based off of right here. If you go to the website that I've created, if you go to Lead Forward to Resources, it'll give you a very good organized chart of all of the TEKS. And so I want to show you what this looks like in first grade. So in first grade, remember, these process standards are how you chose to teach your TEKS. Here we have some skill statements, but place value is actually in reporting category 1. And this is something you could definitely use for your lesson plan this semester. You'll see here in first grade, we use objects, pictures, and expanded and standard form to represent numbers up to 120. And if you come over here to this yellow column, you will see TEKS that support that. Your students in first grade need to be able to expand numbers up to 120, and in ways that we've already looked at and that we'll look at as we do our examples as well. I want to show you, though, as you go to second grade, those TEKS are going to look similar. But in second grade, if you look here, now we're going to 1,200. And there's also a few more TEKS that you can see. Use comparative language, expand these numbers, look at word, standard, and expanded form. And as you see, going into third and fourth, those numbers are going to get larger and larger. And so you need to know when you create your lessons, if you're doing a second grade lesson, you don't need to have an activity or a worksheet to go with your lesson that involves numbers over 1,200. If you're doing a first grade lesson, you don't need to have a worksheet or an activity that goes over 120. All right, going back to our notes, let's go ahead and start looking at some examples. And so right here in the first one, I want you to take that standard, that numeral form, and I want you to write it in expanded form. So if I have the number 7,853, to expand that, I could say that is 7,000 plus 800 plus 50 plus 3. And that's a very basic way of expanding that number. Once your students get to third grade, they might be asked, or they will be asked, to even write it like this. 7,000 is 7 times 1,000. 800 is 8 times 100. 50 is 5 times 10, and then plus 3. So that's another way of writing that same numeral. Your students might even be asked later on to say, okay, 7,000 is 7 times 10 to the third, plus 800 is 8 times 10 to the second, plus, and you get the idea there, but I want you to see here that there are different ways of writing expanded form. Going on to the next problem, I want to give you the expanded form, and I want you to go back and write it as the base 10 numeral. So when I look at this, 8 times 10 to the fifth, that is 8 with 5 zeros. So 8, 1, 2, 3, 4, 5. That lets me know that that is the number 800,000. Plus 6 times 10 to the second is 6 with 2 zeros, plus the 2. So I know now, and I can write it as the numeral, what I have here is 800,602. You'll hear a lot of people say 602. That is not correct. The word "and" mathematically places a decimal there, and there is no decimal before the 2. So make sure if you're pronouncing this as a teacher, you write it as 800,602. All right, on number 3, I'm going to give you it in word form because basically we're going from word to numeral to expanded form. So I'm going to take this word form and I want us to write it as the Hindu Arabic numeral, which is just the base 10 numeral. I have 2,035,701. So I'm going to start off with 2 trillion. Notice I don't have any billions here, so I'll just fill in with zeros there. I have 35 millions, so that's going to be a 035. I don't have any thousands here. And I have 701. And so that is that number as a Hindu Arabic or a base 10 number. It's crazy on test all the time. I will put a numeral on there and have the students write it out in words or do the words back to numerals. And if people miss these kind of problems all the time, even though they do seem very basic. So make sure you know how to go from word to standard to expanded form in our base 10 number system. And remember, you'll be teaching that in the very early grades. Also in the very early grades, we start recognizing or demonstrating or using manipulatives to demonstrate this using base 10 blocks. I hope that your school has enough funding to buy you a set of base 10 blocks. You can always find some online. So I want to show you, if you go back to this page that I've created, if you go to Curriculum Resources, we have a Symbaloo here. It's the second one. And I'll come to this a lot because on this page here there's a lot of different online manipulatives. Here, this is abca.com. And as you're writing your lesson plans, I encourage you to use any of these resources. But first grade, under first grade, there's a very good manipulative for base 10 blocks. And so I want to pull that up, get down here to the math stuff. So right here we have some base 10 blocks. And as I pull this up and press play, here we have this manipulative that you can use. So here's thousands, hundreds, tens, ones, however many you need. And so this is very good if you hand these out in class, but you want to demonstrate to your students very good manipulative. There's tons of these online. If you need to go bigger than thousands, you can definitely find those. Should be able to with no problem. So as far as terminology, I want you to know that we call the 1 block a unit, the 10 block a long, the 100 block a flat, and the 1,000 block a block. And so you can see all those equivalencies there. Kinds of problems that you'll come across as you do your homework is, what is the fewest number of pieces you can receive in fair exchange for 2 flats, 14 longs, and 12 units? And definitely I could go back here and pull that up for you so I could start over and I could pull up 2 flats. But for sake of time and because I know you know these numbers already, we have 2 flats. So I can say I have 2 flats. I have 14 longs. And I have 12 units. And so when we think about exchanging pieces, as you teach our base 10 number system, your students should know that 10 units is equivalent to 1 long. And so what I would show them, and I would definitely at a younger age show them using the blocks, but because you should already be aware of this, what I'm going to do is I'm going to take away 10 of these, and that's going to leave me with 2 units. But 10 of these is going to come over here, and it's going to add a flat. And so now what I have is 15 flats. And definitely you could draw out all 15 if you wanted to. Now you should know that 10 flats is 10 longs, excuse me, is equivalent to a flat. So let me say this again. Here I took away 10 units, and that gave me a long. I have 15 longs, but 10 longs is equivalent to a flat. So I'm going to take away 10 of those. That's going to leave me with 5 longs now. But these 10 longs here gives me another flat. And so what I have now is I have 3 flats. So exchanging those for fewer pieces, I don't now, if you notice here now, I don't have anything here larger than 10 because 10 of these can be exchanged going up a place value. So when I look at here, what I could have, what's the fewest number of pieces I could have? I could have 3 flats, 5 longs, and 2 units. That would be the fewest number of pieces, and we can recognize that this is the number 352. All right, let's do another one like that. So going on to the next page, same type of problem. What's the fewest number of pieces you can receive in fair exchange? I have here 1 flat, plus I have 9 longs, and I have 24 units. And definitely if I was teaching in elementary, I would draw out 24 units, or I would hand them 24 units, I would hand them 9 longs, I would hand them 1 flat. I would not use this multiplication notation like I'm doing here with you. So here, anytime you have 10 of something, you can exchange it. So what I'm going to do is I'm going to subtract 20 here. I'm going to be left with 4 units, but what that's going to do is it's going to give me 2 more longs. So I have 11 longs now. Now 10 longs is going to give me a flat. So I'll subtract 10, leaving me with 1 long, and that's going to give me here 1 more flat. So what I end up with is I have 2 flats. The number that I end up with numerically is the number 214. Now as far as number of pieces, I have 2 flats, 1 long, 4 units. So 2, 3, 4, 5, 6, 7. I end up with 7 pieces. So you can see more examples of that in your textbook, and if you need more, you're welcome to watch the extra lecture video that's in my math lab as well. All right, we're going to move on to bases other than base 10. Some people have seen this before and it's very easy for them. Usually when I get students in this class, the majority of my students have never learned other base systems other than base 10, and so it's very foreign to them. But it's something that if you work with for just about 15 minutes, it should become very easy for you. I do encourage you, if you're still struggling with this after this video, to watch the video on my math lab. Go on YouTube and just search other number-based systems. Make sure you've looked at page 92. But basically, base 10 has 10 digits, 0 to 9. And so after we get to 9, we get a 10. So it takes 10 pieces to go up to get a 10. It takes 10 tens to make 100. It takes 10 100s to make 1,000. And so we keep moving up, but we have to have 10 of something to keep going up in our place value. When you're in base 5, the largest digit is 4. And once you get to 5 of something will move you up a place value. So if you're in base 5, you will not see a digit larger than 4 in that system. To understand this base 5 system, here's what you need to think about. Think of 4 like 9. Right after it, once you get 5, because it's base 5, once you get 5, that makes a 10. And so you move up in your place value. So what I want to do first is I just want to write out what the numbers would look like. So in the base 5 system, we start with 0, 1, 2, 3, 4. But 5 of something is going to make a 10. So the next number would be 10, 11, 12, 13, 14. But that's 5 more. We're about to have 5 more, so that's going to be 20. And so we would move on like that. But notice you never see a digit larger than a 4. That's all the digits, 0, 1, 2, 3, 4. Those are the only digits that exist in the base 5 system. So if you think about what number comes after 34, remember we would have 30, 31, 32, 33, 34. 34 is like 39 in base 10 system. So the next number would be 40, and we write 5 down here to say it's 40, but we're using the base 5 number system. If I say what number comes after 44, I want you to think. There's no such thing as a 5. We can't say 50 base 5. The largest digit is 4. We're about to have 5 tens, and 5 of anything moves us up a place value. So after 44, we would have the number 100, base 5. And like I said, if you've learned this before, this should be very easy. If you haven't, watch this video again, watch the extra video on my math lab, watch some YouTube videos, email me if you need more help with this. It says the next question, what is the largest 3-digit number in the base 5 system? So I want to talk about the base 10 system. The largest number in the base 10 system is 999. Comparable to that in the base 5 system is 444, base 5. And to me, something that really helps here is to think about this as far as base blocks. We won't call them base 10 blocks. These will be called base 5 blocks. But here, if you have 2 blocks, 7 flats, 8 longs, and 9 units, we want to do the same thing. We want to do that fair exchange. Before, in our base 10 number system, it took 10 of something to move up a place value. Since we're in base 5, it takes 5 of something. So here, I'm going to subtract 5 units, which leaves me with 4 units, and that's going to add a long because it takes 5 of something to move up a place value. Now I have 9 longs. From those 9 longs, I will subtract 5, and that's going to leave me with 4 longs. When I subtract that 5, that gives me now a flat. So I have 8 flats. But remember, 5 will move me up a place value. So I subtract 5, and that leaves me with 3 flats. Subtracting 5 gives me a block. And so I have 3 blocks. Now, if I've done this correctly, we shouldn't have any number left over that is bigger than a 4 because I have converted this and moved over place values because 5 of something is going to move it over. And so what I have here now is I have the number 3,344 base 5. At the bottom I have the idea is to subtract groups of 5 because it takes 5 units to make a long, 5 longs to make a flat, and 5 flats to make a block in the base 5 number system. All right, so remember, we're talking about bases other than base 10. So you can talk about base 2, base 3, base 4, base 5, base 6, etc. The next example we're going to focus on is base 3. So in base 3, it takes 3 of a unit to make a long, 3 longs to make a flat, 3 flats to make a block, etc. We're looking at powers of 3, but we're comfortable with powers of 10 in our number system. The largest digit in base 3 is 2. So first thing, to understand base 3, 2 is comparable to our 9 in our base 10 number system. So writing out the digits, we have, first of all, 0, then 1, then 2, but 3 would make a 10, so this would be 10, 11, 12. After 12, you would have 20, 21, 22, but there is no 30. The largest number in base 3 is 2. So remember, 22 is comparable to 99. So my next number would be 100, 101, 102, etc. And so those are our digits, or our numbers in base 3. If I ask you what number comes after 112, base 3, there is no such thing as 113 in base 3. We're about to get 3 more units. See, we had 100, and then we had, 101, 102, 110, 111, 112. There's not 113. My next digit would be 120, base 3. What comes after 122? Well, there's no such thing as 130. There's no digit of 3. My next number after 122 would be, that's like saying 199. My next number would be 200, base 3. And this is one of those things that if you have not ever learned before, it is different. We are very comfortable in base 10 because that's what we've learned all of our lives. Let's go ahead and look at one more example like this. What is the largest 3-digit number in the base 3 counting system? And so this actually goes with the last problem. So what is the largest number in the base 3 number system? Basically, what's comparable to our 999? This would be 222, base 3. All right, and I'm sorry this looks like this. This is actually 2 separate problems. It looks really close together. Next one says, write the first 15 counting numbers in the base 6 system. So if you're in base 6, the largest digit is 5 because 6 of something would move you up to the next place value. So I have, when it says counting numbers, that excludes 0. So counting numbers will be 1, 2, 3, 4, 5. Now I'm about to have 6, but 6 would make a 10 because I'm in base 6. So this would be 10, 11, 12, 13, 14, 15. And my next number would be, obviously, 20, 21, 22, 23, 24, 25, and then I have obviously 6 more, so that's going to give me 30. Now I think I've gone way past 15 counting numbers, but I just kept going. So definitely that's how you would keep going with base 6. You never actually use a 6. 5 is the largest digit, and this would keep going, but this problem said just write down the first 15, and so we surpassed that. All right, last thing we have in this lesson is Roman numerals. Now this should be much more comfortable to you. A lot of us recognize the Roman numerals. My kids are very young and they even recognize them because of the Super Bowl. One thing some people are not familiar with, and let me see if I can go here. used to, if you look at our money, some old images of money, you will see, and I like to look here, here's a $5 bill, an old $5 bill. You can see that there's a 5 on one side, but the V on the other side. So definitely our money system did use Roman numerals a lot more. If you look at the $1 bill, we see this Roman numeral, and that's still there, and we'll talk about that here in a little bit. But definitely on our money, we did used to see more Roman numerals. And so if you kind of just pull it up and look at it, you can see here's another $5 bill. And so when I'm teaching, there's times that I just get on Google and I'll pull something up because that's the way our students are going to do it. They're very comfortable with technology. Let's go back to your notes. You need to be familiar with these. You're going to be tested on these. And so the best thing when you're doing your homework on my math lab, make sure you spend time and you take good notes and you write down the problems you're doing, because once you get to your exams, remember on the homework, you have unlimited tries on those homeworks. But once you get to your exams, you're only going to have one attempt per problem, and you need to make sure that you're comfortable with all these Roman numerals. Note, Roman numerals may also be written in lowercase letters. So make sure you know that M is 1,000, D is 500, etc. There are 5 rules that go with Roman numerals. So number 1, IXCM may be repeated, but never more than 3 times. So that's very important that you know. We never write them more than 3 times. Hopefully you already know the rules for 4. Number 2, when a symbol is followed by a symbol of lesser value, they are added. So if you have, first one, if you have an X and then a V is of lesser value, so that is added. Which leads us to rule 3. When a symbol of lesser value precedes a symbol of greater value, the smaller value must be subtracted. So make sure that you understand this. If it's followed by a lesser value, they're added. If it's preceded by a smaller value, then it must be subtracted. So if it's preceded by a smaller, you're going to subtract it. Like IV, I is smaller than V, so you take 1 from 5. IX, 1 is smaller than 10, so you subtract 1 from 10 and you get 9. And this is where a lot of your 4 and 9 digits are going to come in. Number 4, when a symbol represents a lesser value than either symbols it appears between, then the subtraction rule takes precedence. So make sure you look at these examples. You can pause the video and look at them. It's very simple, and most of you are already going to be familiar with this. So XIV, that X is 10, but then the I is smaller than the V, so 1 is subtracted from 5, so that's really 10 plus 4. On the next one, C is 100. X is smaller than L, so that subtraction rule kicks in. XL is 40, so that's plus 40. VI, V is bigger than I, so that's an addition rule. That's going to be the 6. And so the more you play with these, it's going to be very easy, I hope, for you. Roman numerals are also written according to place value. So 99, you need to write the 90 and then the 9. So 90 is XC. 9 is IX. 3,457, you need to take care of the 3,000, then the 400, then the 50, then the 7. So 3,000 would be MMM. 400 is 100 less than 500, so that's going to be CD. 50 is the L. And then 7 is VII. And so what we'll do now is we're going to do some examples going both ways, going from Roman numerals to numerals here, and then we'll go from here to our numerals back to our base 10 numerals back to Roman numerals. So looking at the first one, we look at our rules. We know that L is 50, II is 2. So the first one's pretty simple. L is 50. II would be 2, and so my base 10 numeral would be 52. All right, looking at number 2, X is smaller than L, so I have that subtraction rule. I take 10 from 50. So this piece right here is the 40. I is smaller than X, And so I take 1 from 10, which makes this piece here 9. And so I know my base 10 numeral is 49. All right, D is 500. And so I have I. That's going to be an addition rule. This is going to be 500 plus 3, which is 503. And remember we said that Roman numerals do not have to be uppercase letters. It can be lowercase. So here, remember, we can never write a Roman numeral more than 3 times. So this M is 3,000. Thousand. D, if we look up, we know that this D here is 500. The CC is 200 more. And the XXX is 30. So if I add up that expanded form, that's 3,730. All right, now let's go backwards. 33. Well, to write 30, I can write any Roman numeral 3 times at most. So that's going to be XXX. And then 3 would be I. So that would be the 30 plus the 3. 600. Well, I can't write 6 C's. Remember, you can't write anything more than 3 times. But I have a 500. So I have a D for 500, then a C to add 100 for 20. That would be XX, and then 1 would be an I. So that would be 621. All right. So I have 1,879. So 1,000 would be my M. 800, I would need the 500 plus 3 100. So that gives me the 1,800. 70, I'm going to need a 50. So my L is 50. XX gets me 2 more 10s. That gets me to 70. And then 9, I'm going to use that preceding lesser value rule. 9 is 1 less than 10. And as long as I placed it before it, it takes 1 away from 10 to give me the 9. All right, last one. 400. I can't write out 4 C's. I have a 500 that I can take 100 away from. So that's going to be CD. I precede it to take 100 away from 500. So that gives me 400. 4, I can't write 4 I's. That's going to be 1 less than 5. So that's going to be IV. And every time I teach this lesson, I always pull up the dollar bill. Let me get back to it. And what I'll do is I'll write this on the board, and I'll ask my students to take that from Roman numerals to base 10 numerals. And if you do that, you will see that it's the number 1776, which should hopefully ring a bell with them. And so that's a good thing to share with them as well. Please go to my math lab, look at this lesson. You have an extra PowerPoint you can look at, an extra video, and also anytime you need extra help, feel free to contact me and I'd be happy to help you.